This is a plate and frame filter press donated to the University of Nevada, Reno from Lithium America. Slurry is sent through the filter press by a sandpiper diaphragm pump. From the inlet hose, the diaphragm pump sends slurry into the filter press inlet. From there, the slurry passes through the first end plate, fitted with a 35 micron non-gasketed filter cloth. Next, the slurry will pass through a primary filtration chamber. Next, the slurry is sent through a mixing plate connected to an air source in order to aid in filtration efficiency. The slurry then passes through a secondary filtration chamber. Finally, the slurry reaches the second end plate, also fitted with the 35 micron non-gasketed filter cloth. Once the slurry passes through the end plate, solids are separated by the filter media, and liquid passes back through each chamber and gathers at the outlet hose where filtrate is collected. Separated solids gather within the filtration chambers and begin to form a filter cake. In industry, and for large amounts of slurry, the mixing plate and secondary filtration chamber may be necessary. However, for a small-scale laboratory setting, both are excluded, and the final system only consists of the two end plates fitted with filter media and the primary filtration chamber placed in between them. An experiment can be conducted by sending a slurry of known concentration and volume through the filter press and recording how much filtrate is collected per unit time in order to determine specific cake resistance, alpha, and filter medium resistance, Rm. This is done by using an integrated form of Darcy's law, where delta P is the pressure dropped observed on the pressure gauge of the filter press, V is filtrate volume collected per unit time, A is the cross-sectional area of the filter medium, mu is the fluid viscosity, Rm is filter media resistance, alpha is specific cake resistance, and Cs is the concentration of solids per filtrate volume. Upon entering the laboratory, students should ensure they are wearing proper personal protective equipment, as demonstrated by Izzy Meza, chemical engineering undergraduate student. She first ensures that all jewelry is out of the way, and then puts her hair up in order to avoid getting anything caught in the equipment. She then puts on protective eye equipment. For this experiment, safety glasses are sufficient. Izzy then proceeds to put on a pair of gloves in order to avoid any irritation caused by the slurry. You'll notice Izzy is wearing long sleeves, long pants, and closed-toed shoes. This is essential for any experiment conducted in the laboratory. To begin this experiment, prepare a slurry consisting of 3,000 milliliters of water and 60 grams of a silica play sand and silica flour blend. The blend should consist of a 27.5 to 1 ratio of silica play sand to silica flour. To reduce particle settling, the batch of slurry is continually mixed by a stir plate. An air compressor is used to power the diaphragm pump. First, the blue air regulator is connected to the yellow extension tubing. Then the regulator is connected to the air compressor. For this experiment, the blue air regulator will be set at 60 psi. Next, the yellow extension tubing will be connected to the diaphragm pump. After a few tries, the pump is connected to the air source. Before operating, ensure all 3 plates are aligned and hand tighten the press closed. Once hand tightened, use the jack to seal the filter press shut. Once this step is complete, the trial is ready to begin. After turning on the air compressor, make sure the regulator is set to 60 psi, never exceeding 100 psi, as that is the maximum operating pressure of the diaphragm pump. Once beginning the trial, filtrate should be monitored at every 250 milliliter interval. Once the filtrate reaches each interval, note the time in seconds. Continue to do this until the slurry is completely gone. Some of the sand may remain at the bottom of the bucket, and much of the liquid will leak into the drip plate. During the experiment, monitor the pressure gauge attached to the filter press. Record the pressure before the trial and after the trial. This will be the pressure drop. Given that a small amount of slurry is sent through the filter press and minimal cake buildup is observed, the filter cake does not substantially alter the cross-sectional area of the filtration chamber, and therefore the analysis will proceed with the assumption that the filter cake is incompressible. From theoretical data for this experiment, time over volume of the filtrate versus volume of the filtrate collected is plotted in order to solve for specific cake resistance and filter medium resistance. The filter press is an incredibly versatile piece of equipment found in a wide range of industries. For wastewater treatment, the filter press is used to dewater sludge and decrease the risk of pollutant runoff into the environment. In the food processing industry, the filter press is used to separate sugar sand from the final consumer product in the manufacturing of maple syrup. A filter press can also be used to clarify pulp content from fruit juices and remove impurities from edible oil such as olive oil. Overall, the filter press is an essential and incredibly versatile piece of equipment.